Here we consider another example of root test. This is the question. Discuss the convergence of summation n equals to 1 to infinity 1 plus 1 by root over n to the power n minus n to the power 3 by 2. So the given series can be written as summation n equals to 1 to infinity an, where we take an equals to 1 plus 1 by root over n to the power minus n to the power 3 by 2. Since here also arise some expression to the power n, so we apply the root test. So limit n tending to infinity an to the power 1 by n equals to limit n tending to infinity 1 plus root over n to the power minus n to the power 3 by 2 to the power 1 by n. This is becomes n to the power 3 by 2 into n to the power minus 1. Since 1 by n is n to the power minus 1 and we know a to the power n to the power p equals to a to the power mp. Here minus n to the power 3 by 2 and here 1 by n. So 1 by n can be written as n to the power minus 1, and this we product this two expression n to the power 3 by 2 and n to the power minus 1. So from this we have 1 plus 1 by root over n to the power n to the power 3 by 2 into n to the power minus 1. So this is becomes n to the power 3 by 2 into n to the power minus 1. So n to the power 3 by 2 minus 1. So n to the power 3 by 2 minus 1, 3 by 2, 3 minus 2. So n to the power half. So this is becomes n to the power half. This is the total expression. So limit n tending to infinity an to the power 1 by n equals to limit n tending to infinity 1 plus 1 by root over n to the power minus root over n. Since n to the power half means root over of n. Now we assume that root over n is t. Let t equals to root over n. So replace root over n by t here also, and here also. Since n tending to infinity, so t also tending to infinity. This is the expression. This expression also can be written as 1 plus 1 by t to the power 3. Now taking limit, we get 1 divided by limit t tending to infinity 1 plus 1 by t to the power t. This is the final expression, and we know that limit n tending to infinity 1 plus 1 by n to the power n, which is e, and e lies between 2 to 3. This we already know. So if we replace t by n, then we get e. So this becomes 1 by e, and since e lies between 2 to 3, so 1 by e lies between 1 by 3 to 1 by 2, and this value is less than half, that is less than 1. So we finally have n equals to limit n tending to infinity n to the power 1 by n is up, which is less than n 1. So n becomes less than 1. So by good test, we say that the given series is convergent. So the given series, this series is convergent. Discuss the convergence of summation n equals to 1 to infinity n plus 1 to the power n plus 1 to the power n into r to the power n divided by n to the power n plus 1. So the given series also can be written as summation n, where n equals to n plus 1 to the power n r to the power n divided by n to the power n plus 1. This also can be written as n to the power n into n, since you know that a to the power n into a to the power n equals to a to the power n plus n. So this also can be written as n plus 1 divided by n to the power n into r to the power n by n. This becomes 1 plus 1 by n to the power n into r to the power n by n. Since here also some expression to the power n arise, so we must apply the root test. So a to the power 1 by n this expression to the power 1 by n, so this becomes 1 plus 1 by n to the power n into 1 by n into r to the power n into 1 by n divided by n to the power 1 by n. This expression becomes 1 plus 1 by n to the power 1 same, and here r divided by n to the power 1 by n. This is the final expression. So n equals to limit n tending to infinity n to the power 1 by n equals to limit n tending to infinity 1 plus one plus 1 by n into r divided by n to the power 1 by n. Now taking limit n tending to infinity both sides, here and here also. So we have 1 plus 1 by n into limit n tending to infinity r into limit n tending to infinity 1 by n to the power 1 by n. So when n becomes infinity, so 1 by n goes to 0 and 1 plus 0 goes to 1. So this value is 1. Here if we take in limit n tending to infinity r, so we cannot compute from here anything. So we keep same as limit n tending to infinity r, and also here we cannot conclude anything from directly. So taking this becomes y, and numbering is number 1. We give this as number 1. So we assume y equals to limit n tending to infinity 1 divided by n to the power 1 by n. Now let z equals to 1 by n to the power 1 by n. So taking both sides natural log, so we have n to the power minus 1 by n by the property of log. Since we know that log a to the power b equals to b into log of a, here n to the power 1 by n. So here b is, if we comparing a to the power b with n to the power minus 1 by n, so here b is minus 1 by n. So when we apply log, then the power is in the, from power it is in the coefficient part. So here b is minus 1 by n, so we in the coefficient part we have minus 1 by n, and we fix log a, which is here log n. So this expression changes in this kind of expression, which is minus log n divided by n. Now we taking limit both sides, then taking limit tending to infinity, we get this kind of expression, which is also can be written as we enter the limit inside of the log, which is equals to taking minus in the outside and taking limit in the inside. Now taking limit tending to infinity in this expression. So we clearly see that when n goes to infinity, then log of n goes to infinity, and when n goes to infinity, then also this part becomes infinity. So when n goes to infinity, both numerator part and denominator part goes to infinity. So this is the form of infinity by infinity. So this is the form infinity by infinity. So we apply here the L'Hopital's rule. So derivative log of n with respect to n, we get 1 by n, and derivative n with respect to n, so we have 1. So this part becomes limit n tending to infinity 1 by n. This is becomes 0 since n tending to infinity 1 by n goes to 0. So you finally get log of limit n tending to infinity z is 0, which is 0. Which also can be written as log of 1, since we know that so we have log of limit n tending to infinity z equals to log of 1. So taking both sides anti-log, we finally have limit n tending to infinity z equals to 1. That is limit n tending to infinity 1 by n to the power 1 by n is 1. So using 2 in 1, we finally have L equals to limit n tending to infinity r, and this is becomes y is 1. So finally we have L equals to limit n tending to infinity r. So depending on the values of r, the value of L change. Now if r less than 1, then L is also less than 1. So by Cauchy's root test, so by root test, the series is convergent when r less than 1. Since when r less than 1, this L also less than 1. So convergent when r less than 1. And if r is greater than 1, then also L is greater than 1. So by root test, the series is divergent when r is greater than 1. Now if r equals to 1, then L also is 1 from this expression. Since r equals to 1, then limit n tending to infinity applied on 1, which is also 1, so L is 1. You know that when L is 1, then the test is failed. So the test fails in this case. So we put r equals to 1 in the above problem, we get summation n equals to 1 to infinity n plus 1 to the power n divided by n to the power n plus 1, and this is 1 to the power n, so total expression becomes this. Now let summation n equals to 1 to infinity n plus 1 to the power n divided by n to the power n plus 1 is summation an, where an equals to n plus 1 to the power n divided by n to the power n plus 1, and let bn equals to 1 by n. Here we basically apply the comparison test, because in this case we cannot apply the root test when r equals to 1, because since when r equals to 1, the test becomes fails by the root test, so we apply here the comparison test. So an by bn equals to n plus 1 to the power n divided by n to the power n plus 1 divided by 1 by n. So this becomes n plus 1 to the power n divided by n to the power n plus 1 into n. So this becomes n plus 1 to the power n into n to the power n into n. By loss of indices cancelling n, this becomes n plus 1 to the power n divided by n to the power n, which is already can be written as n by n plus 1 by n to the power n. So finally we have 1 plus 1 by n to the power n. N tending to infinity, 1 plus 1 by n to the power n. We already discussed this limit. This is e exponential, and which is non-zero and finite. So the series summation an and the series bn is summation an and summation bn are convergent and divergent together. Now bn is 1 by n, and we already discussed that summation 1 by n is divergent by p-test, since here p value is 1, so this is divergent series. So summation an, that is summation n plus 1 to the power n divided by n to the power n plus 1 is also divergent. So if we summarize the total result, we have that when r greater than 1 and r is 1, then the series is divergent, and only when r less than 1, then the series is convergent. So only for r less than 1 the series is convergent, and that's complete the total problem.